Here we're going to talk about unit circle trigonometry, and this will be our last definition for the trig ratios. All right. Now remember from algebra, the equation of the unit circle is x squared plus y squared equals 1. Now we can graph that in the Cartesian coordinate plane. This is the x-axis and this is the y-axis. And when we graph that, we'll get a circle of radius 1. Looks something like that. Now, if we make a ray from the center to any point on the unit circle, we'll form an angle here in standard position. Now, this point here is x comma y, and what we're going to do is explore the trig ratios on this unit circle. So, as usual, we drop the altitude to the x-axis always and form this reference triangle. Now, this reference triangle is kind of special because we know the radius here, the r, is 1, right? That's the unit circle. And the distance here along the x-axis is related to the coordinate x, and the distance here along the y-axis is related to the coordinate y. All right, so if we look at those trig ratios, let's first look at sine. Sine, remember, is defined to be y over r. But in this case, r is 1. And when r is 1, things get simplified greatly. Sine of theta is simply equal to the y-coordinate. And so that's kind of neat. Now let's look at cosine theta. Cosine is defined to be x over r. And again, r is 1. So we get x over 1, and you can see there x is the same as cosine theta is the same as the x-coordinate. Okay, so with that, let's just be absolutely clear that we have cosine of theta equals x and sine of theta equals y. That's kind of important. That's definitely important here because when I replace x here, I can actually replace that with cosine theta on the unit circle, and y I'll replace that with sine theta. And so what this says is that any point on the unit circle is related to the trig ratios. Pretty cool. Okay, let's do an example here. We have theta equals 45 degrees, and let's explore the point that we get on the unit circle. So again, I'll just draw a unit circle here. The radius is 1. This time we'll mark out specifically 45 degrees. And what we're after is this point right here. Okay? Now that point, we know cosine of 45 degrees is equal to, we memorized from last section, that's square root of 2 over 2, and that's an always. You can get that off your calculator as well. But that's going to be the x-coordinate on the unit circle. Sine of 45 degrees is also square root of 2 over 2, and that's going to be the y-coordinate. All right, so this point on the unit circle is going to be cosine, which is square root of 2 over 2, and comma sine, right? So sine is also square root of 2 over 2. Now, as a check, to absolutely show that it really is on the unit circle, what we would do is make sure it satisfies the equation of the unit circle. And that's x squared plus y squared equals 1, right? That's the equation of the unit circle. So if I make those substitutions, x squared and y squared, I should get out 1. Right? So substituting, we're square root of 2 over 2, square root of 2 over 2. Notice here we get a little bit. We get the square root of 2 over 2 squared, so that's 2/4 plus square root of 2 over 2 squared is 2/4. And then adding, we get 4 over 4, which is equal to 1. So when I plug those points in, it satisfies the equation for the unit circle, therefore it's on the unit circle. All right, let's do another one. Let's look next at maybe 60 degrees. All right, so we're on the unit circle. So we'll draw that. And we'll mark out 60 degrees. Gets me right about there. And again, this could be any point on the circle all the way around. Doesn't really matter. We know cosine of 60 degrees is actually equal to 1/2. And sine of 60 degrees is equal to square root of 3 over 2. And the cosine is the x-coordinate. the sine is the y-coordinate on the unit circle. So this point right here is going to be actually 1/2 comma, whoops, sine of 60 is square root of 3 over 2, isn't it? Sorry about that. So 1/2 comma square root of 3 over 2. And that's going to be that point. And again, you can test that, make sure it works. So x squared plus y squared had better equal 1. And when we substitute those values in, right, this time, we'll put in for x 1/2, and we'll put in for y square root of 3 over 2. Squaring 1/2, we get 1/4. And then squaring square root of 3 over 2, we'll get 3/4. And 1/2 plus 3/4 is 1, and it does check out. All right, so here we have the trigonometry cheat sheet. I'll make a link to that in the assignment. Everything that we're going to need to memorize for this course is on this cheat sheet. So this is a good thing to have handy. And you'll notice on the first page we have this unit circle diagram. It's actually pretty neat. It has all of our special angles in the different quadrants and their conversions to radians. Right? So you can see here 30 degrees is pi over 6 radians, 135 degrees is 3 pi over 4 radians, and so on. Now it also has the trig ratios. So we just learned that the first coordinate on the unit circle is cosine, and the second coordinate on the unit circle is sine. So by looking at this, I can see that cosine of 60 degrees is 1/2, and sine of 60 degrees is root 3 over 2, right? Because the coordinates are listed. And notice the coordinates are listed for all the points. So this is pretty handy. So right away I could see cosine of 5 pi over 4 is negative root 2 over 2 over here in quadrant 3. All right, so I cut this out, and I'll show you how this works with particular examples. Here we have some examples, and this is our unit circle diagram. Cut it out. So we're going to use this unit circle diagram to answer these questions. Certainly you can make sure your calculator is in radian mode, and you can do all of these on a calculator and get the exact answer. All right, but we're going to do these using the unit circle just to see how it works. All right, so we're going to begin here with cosine of 5 pi over 3. So we look for 5 pi over 3 on our unit circle. And we come all the way around and we see 5 pi over 3 is over here in quadrant 4. And we actually want cosine. So cosine is the first coordinate. So cosine of 5 pi over 3, looking at the unit circle here, is actually the ratio 1/2. Right? So I can see that that's actually just 1/2, and I can put that there. All right, so next up, they want us to find sine of 7 pi over 4. So looking on my unit circle diagram, I can see 7 pi over 4 lands me over here again in Q4. And 7 pi over 4, this time we're looking for sine. So sine is the y value in the coordinate. So I'm looking there, and I can see that's going to be negative root 2 over 2. Negative root 2 over 2. So hopefully you can see this is pretty handy. 7 pi over 6. So the next one is cosine of 7 pi over 6. So we find 7 pi over 6. And that's equivalent to 210 degrees over here in quadrant 3. Right? So cosine is the x-coordinate, right? So negative root 3 over 2. And then finally, 2 pi over 3. Sine of 2 pi over 3. 2 pi over 3 is terminating here in quadrant 2. Right? And so that's equivalent to 120 degrees. And there we're looking for sine. Sine is a y value, so that's going to be positive root 3 over 2. And that's how you can use the unit circle diagram. Okay, now, certainly you can do all those on a calculator. But now, how do we find tangent from the unit circle diagram? So in this case, we want tangent of 5 pi over 6. The unit circle diagram only gives us cosine and sine. So what we're going to do is we have to know that tangent is actually sine over cosine. So this is equivalent to sine of 5 pi over 6 over cosine of 5 pi over 6. So to find tangent, you've got to take the ratio of the y value to the x value. All right, so in this particular case, we're looking for 5 pi over 6, which terminates here in Q2. It's equivalent to 150 degrees, 5 pi over 6. And so the ratio for sine is 1/2, right? It's the y value. And the ratio for cosine is negative root 3 over 2. So sine is, or tangent of 5 pi over 6 is sine of 5 pi over 6, which is positive 1/2 over negative root 3 over 2. And then the 1/2s cancel, and you just get negative 1 over root 3. And again, you can get that on a calculator. I'm not going to rationalize that. Let's do another one. What if they wanted us to find tangent of 4 pi over 3 radians? Okay, so I know tangent is sine over cosine, so I would write sine of 4 pi over 3 divided by cosine of 4 pi over 3. And then I would look for 4 pi over 3 on my unit circle. And there it is. 4 pi over 3 lands in Q3. It's equivalent to 240 degrees. And so the sine is negative root 3 over 2, and the cosine is 1/2. So we have negative root 3 over 2 over negative 1/2. And often you can do that mentally. And the 1/2s cancel, the negatives cancel, and I get root 3. So there you go. You can get sine, cosine, and tangent from the unit circle. And then from there, if you needed secant or cosecant, you just reciprocate, right? Whatever you get for sine, cosine, and tangent. Lastly, I want to talk about quadrantal angles, or angles that land on coordinate axes. So here's my unit circle diagram. And the first quadrantal angle that I see is 90 degrees, right? That's the positive y-axis there. Or I suppose we can start with 0 degrees, but I'm going to start with 90 degrees. From our unit circle diagram, I can see sine of 90 degrees is equal to, so here's 90 degrees, sine is a y value, so I see there a 1. So sine of 90 degrees is 1. Cosine of 90 degrees, cosine is the x value, right? So I see there a 0. Now if I were in radian mode, I could see that 90 degrees is equivalent to pi over 2 radians. In other words, I can write sine of pi over 2 equals 1, and cosine of pi over 2 equals 0. Okay? So from that, I can see then that tangent is sine over cosine. So sine of 90 over cosine of 90. And when I substitute that in, I'm going to have 1 over 0, which is undefined. Right? So the tangent there is 1 over 0, undefined. And that's true. You can do that on a calculator and see that you'll get an error. Tangent, let me clear that out and show you real quick. Tangent of 90 degrees is a domain error, right? Because we're dividing by 0. All right, let's look at another quadrantal angle. Let's look at, say, 180 degrees or pi. We could say sine of 180 degrees from our unit circle diagram. Sine is a y value, so we get 0. And cosine of 180 degrees, I could see there is going to be negative 1. Again, in radian mode, we would say sine of pi radians is equal to 0. And cosine of pi radians is equal to negative 1. Those are equivalent. Now, when I look at tangent of 180 degrees equals sine of 180 degrees over cosine of 180 degrees. And so in this case, sine over cosine, we get 0 over negative 1. 0 over negative 1, that's just 0. And so tangent of 180 actually is 0. That's defined. Let's see that. Tangent of 180, certainly, we get 0. Perfect. And that's how we can use the unit circle diagram. Now, you can see here there's all sorts of quadrantal angles. You got 0 degrees, 90 degrees, 180 degrees, and then right here you got 270 degrees, which is equivalent to 3 pi over 2. And there's your cosine and sine values.